So in today's class we'll discuss about this is the first lecture on AutoCAD, that is CAD1, your practical class on CAD1. So before that we'll discuss about what do you mean by a drawing. So drawing is a pictorial representation which is represented in a drawing sheet. This is the pictorial representation of a practical objects, various objects like building, bridge or any other structures. Okay, these are drawn in a drawing sheet. Okay, so these are called drawings. Now in drawing various projections are used, as you already know in your first year drawing class, like first angle projection and third angle projection. So let us see that. So now let us discuss an aspect of drawing. This is first angle and third angle projection. As we can see, this is the first angle projection in which the plan is drawn below the section of a building, and in third angle projection the plan is drawn above the section of the building. So this is one important aspect of drawing. Then another aspect is your RF factor, which is called representative fraction. So in RF factor, this is the ratio between the dimension or length of a line. Suppose if we consider a line on a drawing and and in actual field condition, as we all know, actual field condition, that length of the line is more than the line in the drawing, because drawing sheet has its own limitation. So actually, suppose actual in field condition a line has a length of 50 meters, suppose. So but we cannot provide this 50 meter line in a drawing sheet, so we consider a RF representative fraction to show this line, this actual 50 meter line to accommodate this line in a drawing sheet. Okay, so suppose this is 50 meter line, then then in drawing sheet, suppose we take this 50 meter line as a 5 centimeter line. Okay, so the ratio between the length of line in a drawing sheet divided by actual length. So length of line in drawing sheet divided by length of that line in actual field condition gives us a factor known as representative fraction. So this ratio is most important while draw any building in a drawing sheet, any structure in a drawing sheet. So now consider this drawing. As you all estimate, as you all see in the estimate, you also do building estimates like single room building estimate or 2 room building estimate. So from that we can consider this drawing. So this is a 2 room building estimate, a building drawing. Okay, so in this drawing, as you all can see, this is the plan of the building. So this is first angle projection. The drawing is in first angle projection as the plan is drawn below the section of the building. Okay, so in this plan, as we all can see, there are 2 room buildings. So this is one room and this is another room, and size is written below the naming of the room. So this is 4.5 meter into 3.6 meter. So room size, interior size is 4.5 length and 3.6 meter is the width of the room. So here also it is written 4.5 meter and the width is 3.6 meter. Similarly, the width of another room is 4 meter by 3.6 meter. The 4 meter length and width is 3.6 meter. And here you can see it is the width of the wall. It is 30 centimeter width of the wall. And similarly, this is wall junction So this partition wall connect with this main wall, outside wall. So this is the wall junction, and here there are two number of doors. This is door number 1, door number 2. So it is written as a symbol D. Similarly, all the windows are shown by symbol W, and the dotted line is shown for the projection for the charger which is provided above the window. Okay, so this is the detail of the room. Next, in front of the two rooms there is a veranda. The veranda size is veranda length is equal to the length of the two room. If we add the length of two rooms, then we get the total length of the veranda. Then width of the veranda, here it is given as 1.6 meter, and there are 1 2 3 4 5 number of pillars of size 20 centimeter by 20 centimeter. And in front of that, the main gate, in front of the main gate there is steps are provided. So here the sectional details. On section on PQ, as it is written section on PQ, you can see the PQ section. The section is drawn by cutting a wall or any other structure and see from side of it. Okay, here PQ, you can see the arrow mark here. That means we can see from this side, from right side of the section. Then we can see like this section we can see. So in this section it is shown the substructure details, the foundation details, the footing, plinth wall, steps, sectional details, and above that there is superstructure wall details also given, and roof structure sectional details also given, and it floor details also given. Okay, so next come to this section on PQ. In this section the wall footing is of width 70 centimeter, of thickness 30 centimeter. Above that first footing is of width, here it is written 40 centimeter, and thickness 20 centimeter. And above that there is plinth wall of height 60 plus 40. This is below ground level. Plinth wall height is 40 centimeter. Above ground level plinth wall height is 60 centimeter. So total height of plinth wall is 60 plus 40, that is 1 meter. Okay, so here it is also written P dot L. P dot L means plinth level. Okay, then this is all about below plinth level there is floor details also given. Okay, this is the floor section. So up to floor level or up to plinth level, normally plinth level and floor level coincides each other, and above plinth level we have superstructure. Now what do you mean by substructure and superstructure? Substructure means the structure below plinth level or floor level, we call it as substructure. In substructure there are foundation, footing, plinth wall, then steps, flooring, these all comes under, or any earth filling in between the plinth wall, there are earth filling, these all comes under substructure. Then above that, above plinth level or above floor level, we have superstructure. And the superstructure consists of superstructure wall. In this drawing the superstructure wall is having thickness 30 centimeter. So superstructure wall, then beam, then pillar or column, then above that the main roof of the building, and above the roof there is parapet. Here it is shown 10 centimeter. This is thickness, this is parapet over the roof. So these all comes under superstructure wall, the superstructure components of a building. Okay, so here PQ section cuts through the veranda section. Okay, so as we can see from right hand side, then we can see the pillar. So here the pillar is shown. So this pillar is having size 20 centimeter by 20 centimeter. So the pillar is with height of 2.7 meter. The pillar is having height of 2.7 meter. Then above that there is lintel. So lintel beam has the work to support. Its purpose is to support the structure above it or the brickwork above it. So the wall above lintel is supported by this lintel. So and this projection is called chaja. Okay, so its width is 45 centimeters. So this is also shown in section. As in the plan section, this is shown in dotted line. So in section, this is shown by solid line. Okay, solid line with shading. Hello. So above that, now above the wall there is roof. The roof details is also shown in another section. Above that, parapet wall of thickness 10 is shown. Okay, so this is the section, this is the details on section on PQ. Then come to sectional elevation on ABCD. Now you can see AB, this is C point, this is D point. That means we cut the drawing in this way. We can see from this way, arrow mark is here. So we see from front side of the building. So AB line, then BC line will cut through the veranda, through the main wall, door section, and then from C, there is a section called CD which cuts through another door in the partition wall and this window section. Okay, so the sectional details through A, B, C, D will be shown in this sectional elevation on ABCD. Okay, so here this is the AB section. From this to this is the front side of the building. Okay, there is no cutting. This is front side of the building. Then after cutting in CD section, CD line, sorry, this is AB line. Then after cutting, BC line will cut through the step, through the veranda, through the main wall, and through the room. So that is shown here. This is the CD line. Okay, then sorry, this is BC line. Then C to D will cut through the door in the partition wall, then window section. So if we see from front side, after cutting CD line, the building, if we see from front side, then we can see the building like this. So here the foundation details also shown, foundation detail of the partition wall, and this is the foundation detail of the main wall also shown. This is the floor details. Okay, now the section line will cut through the both substructure and superstructure of a building. Okay, these two back windows also shown. Okay, and above that the roof is also shown. The roof is having thickness of, its detail also given, 10 centimeter RCC slab or roof. Its thickness is 10 centimeter. Above that lime concrete of 10 centimeter is provided. Okay, above that parapet is there, and the schedule of door, window, frame, shelf, etc. are given. Okay, so these are some of the standard dimensions of door and window. Also we discuss various dimensions of room, door, window, ventilator, etc. in another drawing. So okay, so this is the plan and sectional elevation of a building. This is all about plan, sectional elevation. Okay, so now we discuss about various standard dimensions of a building components. Okay, so first is your bedroom. So the size of bedroom is fixed in between 3000 into 3600 to 4200 to into 4800. So this, in this in between this dimension the bedroom size is fixed. And next is your drawing room. Its size also 4200 into 4.2 by 4.8 to 5.6 5.8 into 7.2. Then your kitchen size is also given. Then dining room. So please note all the standard units, standard dimensions. These are written in mm. Then plinth height is normally fixed. As you can see, plinth height is fixed 300 to 600 mm. Okay. So this plinth height is above ground level. Please note this is above ground level. The plinth height is fixed in between these dimensions, lengths. Then size of door, these are the standard door size 1200 into 2100 mm. Then for toilet bathroom, small size doors are used of size 800 into 2100. Then size of window is provided in between 750 into 1000 to 1200 into 1200. Then wall thickness is 200 to 300. Normally partition wall is having thickness either 10 centimeter or 20 centimeter, and main wall is normally provided of 1/2 brick thick wall or this 300 mm. Then charger projection, this is 450 to 600. So these are some of the standard dimensions which we can follow while draw any building structure. Okay, so here you can also see the steps having rise 150 to 200 and tread having size 230 to 300. Then depth below ground level 800 to 1200. So please note all the standard dimensions. Now let us discuss about Autocad. The full form of Autocad is Automatic Computer Aided Drafting and Designing, and it is developed by Autodesk software, Autodesk, in 1982. Now, why we use Autocad software? Some of the merits are like this. These are the merits or advantages of using Autocad software over manual drawing. In manual drawing, we use drawing sheet, pen, pencil, etc., rubber, drafter, etc. we use, and this is a time consuming activity. But in by using Autocad software, we can easily draw any structural drawing, any object, any drawing of any object easily by using some commands. Okay, so and the Autocad software, the drawing drawn in any component drawing can be easily shown by soft copy, and we can easily edit in future, we can easily modify in future that particular drawing, and it is less time consuming, and it is very much easy to draw any Autocad drawing as compared to manual drawing. So due to this, we use nowadays Autocad replaces nearly replace the manual drawing. So this is our system. In this system, Autocad is loaded. Autocad 2017. It is English version, as you all can see. Now let us open it. So now loading of the Autocad. This is Autodesk Autocad 2017. It is written on the top. Now next screen like this comes. Now we can click get started. This is start drawing. You can click start drawing. Okay, now this is the main screen. Okay, before this, first let us know the basic layout of our keyboard and mouse. So in the keyboard, in the top there are some keys. This is escape key. These are the function keys which are the shortcut of various commands which are very useful while doing any AutoCAD drawing, while drawing any AutoCAD drawing. So then there are some numeric keys 1 2 3 4 etc. Then alphabets. Okay, by typing these alphabetic keys we can also give command to AutoCAD. Okay, then here this is up down arrow. and these are also numeric keys. Okay, so this is enter, shift. So all these keys are useful while entering various commands. Then come to, this is our mouse. This is this is the left click. By selecting while opening any command, we can use this left key, and this is cursor. To zoom in or zoom out, we can use this cursor option. Then right click. So in the main screen we can see this is x coordinate, this is y coordinates, this is user coordinate system. This is called UCS in short form, or this is known as user coordinate system. And in the left hand side we can see, if we place the cursor over this toolbar, we can see this is written draw. That means this is draw toolbar. Then in the right hand side we can see this is view toolbar. Okay, this is view toolbar. By using this view toolbar, we can view various sides, either top side or various sides, right hand side, left hand side. We can see various sides of a structure or any object. Then below that there are various tools, like for zooming in or orbiting any object, like these tools are used. And in the right hand side we can see this is modify toolbar. If we place cursor, you can see it is comes out to be modify. So this is the modify toolbar. Then above this there is a arrow mark. If we click the left click, then we can see various options are there. In this the tick mark, if in an option there is tick mark, that means this is active in your main screen. Okay, then there is one option like hide menu bar. By clicking this option, we can hide or unhide the menu bar. Now let us see what is the menu bar. This is file, edit, view, insert. These commands are written. This line is known as menu bar. Okay, so if we suppose, for example, if we click this toolbar, then there are various options are there, like workspace, palette, toolbar, command line, etc. By selecting all these, any of this we can activate in our main screen. So then there is ribbon. This line is called ribbon. In this also various options are there, like home, insert, annotate, parametric. Okay, so this is called ribbon in a AutoCAD software. Okay, then below this we can see this is an important aspect of AutoCAD. This is command line. This line is known as command line. Above that various commands are written, like here for example this is written specify opposite corner or polygon, etc. So below this we can type various commands to show in our drawing. Suppose for line the shortcut is L. If we press type L and enter, then it shows here it is written near the cursor the specify first point. Okay, specify first point. Then we click it, 0 0 comes out. This is the first point. Then if we move the cursor, then the length of the line is written over it. Okay, if we draw any angle through that line, through the horizontal line, then we can mention the specify the angle over this horizontal line. So this becomes polar line, polar coordinate system. Then so this is an example of using command option. Okay, so this is the basic layout of an AutoCAD software. So in the next class we'll discuss about various tools used in the AutoCAD software, like this draw toolbar, or your modify toolbar, or in the bottom right corner these are model or mode toolbars. So let us we'll discuss in the next class about various tools used in the AutoCAD software. Okay, thank you.